We could repeat these calculations for the time interval from 0 to 2 seconds, 2 to 4, 4 to 6. We've already done 6 to 8 and 8 to 10 seconds. The procedure would be this identical in either case. Our velocities, of course, would be 2.8, 3.6, and 6.0 meters per second, in addition to the 4.4 and 5.2. The results that we'd obtain would be as follows. The displacements are indicated by the circled numbers inside of the trapezoids. And each of these numbers was obtained, like the 9.6 that we obtained in the previous clip, obtained by multiplying the average altitude corresponding to the average velocity by the width, which corresponds to the time interval. And we get our displacements here, 4.8, 6.4, 8.0, and 11.2 meters, in addition to the 9.6 meters. Now the table shows us our clock times, 0, 2, 4, 6, 8, and 10 seconds. The velocities that go with those clock times, 2, 2.8, 3.6, 4.4, 5.2, 6.0 meters per second. And then we get the average velocities, the 4.8, I'm sorry, not the average velocities, but the displacements. We calculate average velocity multiplied by time interval to get the displacement on each interval. And then if we want to find S, and this looks like delta S divided by S, and that's just a line to separate the delta S and the S, so don't be confused by that. If we want to find the actual positions, assuming that we start at position 0, well, if at t equals 0, the position is 0 and the displacement is 4.8 meters, then at time t equal 2, the position itself will be 4.8 meters. If over the next 2-second interval we have a displacement of 6.4 meters, then we're going to have a position of 11.2 meters, adding our two displacements, 4.8 meters and 6.4 meters. And this is going to continue until we get the 40-meter displacement at the end.